All right, so we're in chapter 2 now, and this is where we start talking about functions. Functions is a big part of Algebra 2. So we're going to go ahead and start off at 2-1, talking about relations and functions. Relations is just a set of ordered pairs. It's really not a lot to do with relations, but functions are huge. Functions are special relations. So let's go ahead and start talking about those. You can read here that the first thing that we're going to talk about is direct variation. And this, if you see over here, you can see that it is this formula right here, y equals kx. You could solve for k if you wanted to and get y over x equals k. And you could solve for x if you wanted to if you get y over k. There's all sorts of ways that we could solve, just like we did in the last chapter. We call the k in this equation the constant of variation. And we're going to have to be able to find out what that constant of variation is coming up in the next couple slides. So here you have a bunch of ordered pairs set up in tables. That's a relation. And we want to find out if it is a direct variation function. And we would read that y varies directly with x, which we would write out as y equals kx. That's how that's read. Y varies is our equal sign. Whenever we see the word varies, we're going to put equals k. This part right here is varies. All right, that's a giveaway. So what we want to do with these ordered pair is to see if they have the same k in every time. And if you remember, if I solve for k, I'm going to go ahead and solve for k over here. I'm going to divide both sides by x. If I do y over x on each of these ordered pair and it gives me the same k, then we have a direct variation. So let's go ahead and look at that. 2 over 1, 6 over 3, and 8 over 4 are all 2. So we would say that y varies directly as x, and the constant of variation is 2. So we could write out the rule for the function of y equals 2x, because k was 2. Let's do this one over here. Let's do b. 4 over 1, 8 over 2, so far looks good. And then we get 11 over 3. That is not a constant. It does not stay the same. So we would say y does not vary directly as x. So that's one way when you get ordered pairs to see if it varies directly. Just make the fractions of y over x. All the fractions have to be the same. Another way that I could ask you the question if it's a direct variation is to give you a graph. And you could find the points on the graph and do the y over x, but really the easiest way to tell if it's a function is to make sure it's a straight line and that it goes through the origin. Those two things have to happen. If it doesn't go through the origin, it is not a direct variation. If it's not linear, it is not a direct variation. So graphs are real easy to see if they're a direct variation. You're just looking for something that goes through the origin and is straight. Another way I could ask the question if something varies directly as x is to give you an equation. And remember, it has to be a line and it has to go through the origin. So the first thing you might want to do is get this set up into y equals mx plus b. All right, so we want to get the y by itself. We learned how to solve in the last chapter, so let's go ahead and solve for y. I divide both sides by 3, and really I would rather you think of not dividing both sides, but to divide every term. I have two terms, 3y on the left, 7x on the right. I'm going to divide both of those by 3, and I get y equals 7/3 x. So that's a line, because I don't see any exponents, and I don't see a b, so that means it must go through the origin, so that is a direct variation, and the constant of variation is 7/3. Let's look at the second one here. Let's look at b. I don't want you to think of dividing both sides by 7. I want you to think of dividing every term by 7. So I have 3 terms total, so I'm going to divide the 7y by 7, the 14x by 7, and the 7 by 7, and I'm left with this, a nice line. I get me a nice y equals mx plus b right here, but because it doesn't go through the origin, this is not a direct variation. Even though it looks like it has a K, in this sense, that's an M. To be a K, we cannot have the B there, if you want to think of it that way. So up until now, it's been really easy. Basically, you're just kind of doing some simple math. If you're doing any math at all, sometimes you can just look at it and say, oh, that's a direct variation or not. But that's not usually what we do with direct variation. Usually you're going to get a question like this, and they want you to solve for a variable. They're going to give you a situation where it says, well, y varies directly as x, and y equals 9 when x equals negative 15. Then what happens if I change the x? What will happen to the y? So let's go ahead and run through a couple ways to do that. The first way is you could make a proportion like you see up here, right? That is not my favorite way to do it, but you are definitely welcome to do it that way. You just have to remember and memorize what the formula is for that proportion. Y1 over x1 equals y2 over x2, but we can really mess that up sometimes. So I personally prefer that we do it more like this. I'm going to break this off. I like to start out and I read this part right here, y varies directly, and I know that that's y equals k. Because remember, varies directly, the word varies is equals k. Directly tells me that I'm going to put the x right there. And they give me I got 3 variables here, and they're giving me the value of 2 of them. They're saying, hey, y is 9 and x is negative 15. So I'm going to put a 9, and remember, whenever we substitute, we put them in parentheses, right? And I'm going to solve for k. So I'm going to divide by negative 15, and I get k equals, I'm going to reduce that and put the negative in the top. What's that, negative 3/5? So then I'm going to rewrite it. This is my rule. Y equals negative 3/5 x. So now I can go to the actual question and use this 21 where the x goes and just basically do some math. All right, so I'm going to put a 21 in here. All right, and you can use your calculator if you want. I really don't like the decimal answer, so let's go ahead and, I don't like that equal sign right there either. Go y equals negative 63 over 5. And I love this answer. All right, this is a theoretical math question. It's not really a real world problem, so I like improper fractions, even though I don't like the name of it. But if you actually divide that out, you'll see that we got the same answer doing it 2 different ways. All right, so for our last example, a little bit of a word problem here. A salesperson's commission varies directly with sales. So what you could do is you could use y's and x's if you want, or you could use different variables if you want also. Like you could do C for commission, varies is equals K times the sales. Not a big fan of using S because my S's sometimes look like 5s, but that is an option. Just remember that varies is the equals K, okay? But they used in here, they used X and Y, so let's go ahead and do that. So it says for $1,000 in sales, so I take this $1,000 and put it where the S goes. The commission is 85, and I take the 85 and put it where the C goes. Or you could use the X and the Y, like I said, and it looks like this. 85 equals K times 1,000. Do that division, and you get K equals 0.085. So you got your K. Now we could rewrite it. C equals 0.085 times S. Or if you use the X's and the Y's, you'd have X's and Y's there. All right? So now it says, what's the commission? So we're looking for C when sales are 2,300. So I'm going to take this 2,300 right here. I'm going to put it where the S goes, or the X if you use that. And then just throw it in there. Do some math. And this is one of those times that I'm okay with a decimal because I didn't have to round. It's a real world question. So, and we should give it a sentence answer. The commission on $2,300 in sales is $195.50. And that's how you do it.